Hello, my name is Chris Dunn, and I'm the director of the Hydrologic Engineering Center, or otherwise known as HEC. The purpose of this series of presentations is to introduce you to a piece of software that we're really excited about called HEC-WAT, or the Watershed Analysis Tool. This particular presentation is the first of a four-part series. In part one, we are going to identify the need for and policy for systems and watershed approaches with risk assessments, and then introduce you to HEC-WAT, or the Watershed Analysis Tool, and the reasons it was created. Just to let you know, the WAT is currently available from the HEC website and is actively being used on studies today. So what are the objectives of this presentation and subsequent presentation in this series? Well, first, we're going to identify the need for systems and watershed approaches with risk and life cycle cost analyses. Then we're going to introduce you to the Hydrologic Engineering Center's Watershed Analysis Tool, or HEC-WAT. Later, we'll talk about the flood risk analysis compute option in a subsequent presentation. We'll talk about the consequence and performance metrics that HEC-WAT produces and how they're similar to what HEC FDA produces. We'll talk about some field implementations and then the challenges and solutions to using a tool like HEC-WAT. So it should be no surprise to you that the Corps has many requirements regarding systems context, performing studies from a watershed approach using the risk framework. ER 1105-2-100, which is the planning guidance notebook, says the planning process shall, not should, shall address the nation's water resources studies in a systems context. And then ER 1105-2-409 says collaboration is the keystone of the Corps' watershed approach. ER 1105-2-101, which we talked about earlier, says all flood risk management studies will adopt the risk framework. So it's clear that we have to look at our watersheds, do our planning studies from the systems context using watershed approaches in a risk framework. Other pieces of guidance that were around when we first started developing the WAT were EC 1110-2-6067, and there it said that the levee system performs as an integrated set of features. And USACE Actions for Change said required comprehensive systems approaches that included integrated, sustainable solutions, and decisions are risk informed. So very consistent with where we are at today with regards to systems approaches, watershed approaches, and the requirement to use a risk framework. So does FDA satisfy these USACE requirements? Not necessarily, and not always intuitively. So if you take, for example, the figure in the upper left, it has 4 damage reaches. They're in green. Let's say, for example, that a levee in damage reach 4 fails during an event and water moves from the river system into the interior area. Is that water then that's removed from the system, is that then reflected as we move downstream to damage reach 2 and damage reach 1? No, it's not. So FDA does not necessarily work as an integrated system. However, before you go too far, we did have a study a number of years ago, and it was documented in Project Report, or PR 71, where we showed that FDA can be used in an interrelated system. And the title of that particular documentation is called Documentation and Demonstration of a Process for Risk Analysis of Proposed Modifications to the Sacramento River Flood Control Project levees. So in that particular project, we did show that FDA could be used for a large watershed type of a study. The problem is that it just wasn't intuitive as HEC-WAT is. So on top of that, we had Major General Walsh. He introduced the 3x3x3 process or requirements, where you had to do your planning studies in 3 years. There had to be 3 levels of review, and the cost had to be within $3 million. And then I always like to say on top of that, the reports had to fit in a 3-ring binder, 3-inch 3-ring binder. So it really wasn't 3 cubed, it's 3 to the 5th. That said, it introduced new requirements to perform studies quickly. On top of that, you had Major General Temple, who said, well, we have to do fewer civil works projects, do them well, deliver benefits sooner and more efficiently, and still do watershed and system-based approaches. So all of that has to be done 3 years for $3 million. So it's difficult, right? So how do we meet these requirements? Well, we meet these requirements, or one way we can meet these requirements is with the use of HEC-WAT, or the Watershed Analysis Tool. what that tool is, it's a planning and evaluation tool. It's an overarching interface and model integrator for building, editing, running models commonly applied by multidisciplinary districts, and saving and displaying data and results in a coordinated fashion. It meets the needs of performing water resources studies in a collaborative, comprehensive, and system-based approach. And it integrates analytical processes that you would need in a large study, such as the hydrology, the hydraulics, the economics, the consequences, the environmental aspects, and other social assessments. And it provides an effective way to communicate risk to the study team and public. And it can be flexible. It can be used for large studies as well as small continuing authorities programs types of studies. So one of the huge benefits of it is all the data, the modeling can be stored and run from within the WAT itself. So no longer do you have to worry about whether a person moves away or where the data is stored. The data will be stored with the WAT modeling and data files. So what is the WAT framework? So basically, you can start by developing a spatially correct representation or schematic of the study area, and you get everybody in the study team on board with that common representation of the area that you're studying. You can organize and develop alternatives, so it can work for plan formulation, plan evaluation. You can organize and store data, and like I just said, no longer do you have to worry about, hey, all the data is stored on, Joe's machine and Joe retired and I don't know where he stored it. It will be stored with the WAT models themselves. You can run the modeling software right from within the WAT. You can edit the models from within the WAT, and you can view and compare alternatives from within the WAT. So it's a very intuitive tool that allows you to run the models, edit the models, see the modeling results all from one interface. And you can import existing models like SWIMS models. Don't have to be SWIMS models, but you can import existing SWIMS models or the core water management system models, or develop models from within the WAT itself. So you may or may not be familiar with SWIMS. So let's talk about that a little bit. The SWIMS, or the core water modeling system, core water management system, has been developing models for about the last 8 or so years throughout the nation. So the core water management folks has a mission where they have to manage the water across 201 basins throughout the United States. Those basins are what you see here. They're either green, red, or orange, depicted in this particular figure. Green means that the SWIMS models have been built and they sit at the district office. Orange means that the SWIMS models are being built and they will soon be sitting in the district office. And the red watersheds are the areas where we have yet to build the SWIMS models. But what this really means is that you will have hydrology models, HEC-HMS, hydraulics models, HEC-RES, reservoir models, HEC-RES-SIM, and consequence models, HEC-FIA, for every one of those 201 basins. So literally with a touch of a button, you will be able to import the SWIMS models into the WAT. And you think about the benefits of that in trying to meet Major General Walsh's requirement of the 3x3x3 planning process. You'll have essentially high fidelity SWIMS models that will be readily imported into HEC-WAT for your planning studies. So a huge improvement and a huge benefit for the SWIMS teams for the planning teams to capture those models from the SWIMS teams. So the areas in white that you see here, those are 94 other basins where they're still important to the core. It's just that we don't have a water management mission in those areas. So let's say you're in one of those basins and you needed to use the WAT, or for some reason you couldn't use the SWIMS basins for your WAT study. Can you still use the WAT? Well, certainly you can. So if you were to start a planning study, you would start with a blank sheet of paper, a white sheet of paper, and you would come in with no preconceived notions of what you want to find. And as a team, collaboratively, with your local stakeholders, local sponsor, you would start to develop the watershed. First thing you would bring in is the stream alignment. What is the physical area that you want to study? And then you try to come up to an agreement. Is this the area that we actually want to study? Yes or no? If it is, great. If it's not, add to the stream alignment and make it what it needs to be. Next, you identify your consequence areas with your group. And are these the areas that we need to study? Environmental areas, towns, those types of things where you actually want to see the consequences. Then you bring in your what are called CCPs, or your common computation points. The CCPs are where data is handed off from one model to the other model, or it's a location where you want to see and visualize results. If you don't have the CCPs that you want, simply add them and name them. And then you bring in your reservoirs. At this point in time, your team, whether it's your local sponsor, core, state or federal agencies, they can look at this schematic and it has all standard naming, and they can say, is this what we want to study or not? If it is, great. If it's not, you continue to build it until it is. So now what we're trying to do is build trust and build a collaborative environment among our study team. So now that you have this shared schematic, each of the modeling teams can use it with all the nomenclature, all the naming that you've provided, and go off and start to build their models. Okay, so that can happen in the WAT. It can happen outside of the WAT. But let's just say, for example, that it's happening outside of the WAT. Right now, each of your modeling teams are building their models with the shared schematic that you have built. And now you start to import those models into the WAT, and then you bring in your ResSim models, you bring in your FIA models, you bring in your RAS models. And the whole purpose of this is to start and continue to build trust across the modeling teams. You say, fine, I brought in a ResSim model, I brought in an FIA model, I brought in a RAS model. That still doesn't mean that it's any good. True, but what the WAT allows you to do is it allows you to look at the results intuitively right from the schematic itself. So here's the stream alignment, and now what we're going to be doing is we're going to be bringing in the hydrology. So here's the hydrology from the calibrated results. It's either good or it's not. So you either have to say, yes, I agree with that model, or no, I don't agree with that model. Let's assume that it's good. Then you're saying, okay, that hydrology model is pretty good, and I can see that directly from the WAT. And then the same thing with the reservoir models. Is this the water surface elevation in the reservoirs? Is this the amount of flow that we release downstream during that calibrated event? If it is, then great. Now you believe in your reservoir models. Same with the hydraulics. Is the water surface elevation right? Is the flood inundation boundary right for that historic event that you're calibrating your model to? If it is, now you have some belief, trust in the hydraulics model. Same with the consequence model, and you could even do it from an environmental context as well. So what you've done is you've built, with a WAT, you've built a shared schematic that everybody agrees with. You've gone off and done your modeling together or apart, but regardless, you bring those models back into the WAT, you can visualize the calibration results, and you can determine whether the model is a good model or not a good model. Once you've done all that, then you can start to refine the models, look at other alternatives, and move forward. But again, hopefully you've built trust and commonality across the team. So what's specifically in the WAT right now? Well, there's HMS capability, there's ResSim capability, RAS capability, FIA, SSP, EFM, and at one time, there were other software like Geisha, Flow2D, ADH, and Riverware. Those have not been exercised recently, so I wouldn't guarantee that they would work today, but it shouldn't be too much to get them to work again. So this is just a schematic that kind of shows you how the WAT works. Essentially, the WAT is a framework or an umbrella that orchestrates the running of all the other models in a sequence beneath them. And in the bottom, the model and results, that's the foundation for the WAT run. Those are stored in DSS. So for example, let's say you have a WAT model that has an HMS, ResSim, RAS, and FIA component to it. So the first thing that happens is that the WAT framework triggers the HEC-HMS plugin. The plugin is the tool that allows the WAT to speak to the piece of software itself. And so the plugin says, hey, HMS, run. HMS runs. HMS sends all of its results to the DSS file. And now the DSS or the HMS results are now available to ResSim, RAS, or FIA in this sequence of models downstream. So any one of those subsequent models can pick off the HMS results out of DSS. So now the ResSim runs, and the WAT says, hey, ResSim run. ResSim through the plugin runs, and then it sends its model results to the DSS, and so on and so forth down the road. So you can share data across all the models with a common DSS file, and this allows and improves modelers early in the study process and encourages a team approach. The communication between the WAT framework and the models themselves is the plugin. So every time a new version of the software is developed does not mean that you have to have a new WAT instance. The HMS plugin can handle that. And essentially what we're looking at here is an event or period of record type of analysis. This is not the full risk analysis that you need, but it's the basic structure of what the WAT is and how it works. So we have completed the first of 4 presentations in this series introducing you to the WAT. We haven't gotten to everything. In this presentation, we identified the need and policy for systems and watershed approaches with risk assessments. And we introduced you to the basics of the HEC-WAT software. There's a lot more to come. Now would be a great time to capture any questions you have on this session, and we can discuss them in our last discussion session. Thank you. See you next session.